Hey, this is Joe, Gray Bench Electronics. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Kingsley Constable. Okay, Kingsley Constable. So this is a standalone tube or valve preamplifier from Kingsley. They make a bunch of tube amps. They also make these tube-based pedals or valve pedals. So this is a standalone preamplifier. It's sort of like the front half of a tube amp. And it is designed to be used that way, where you either take the output of this pedal and go straight into a standalone power amp, or you can also do it into the effects return of a regular guitar amp, which is usually going to be maybe one gain stage and then phase inverter, or straight to the phase inverter. Kingsley, though, recognizes that a lot of people are just going to put it into the front of a guitar amp, which is going to be then into another preamp. So they do have an output switch here, which has 3 modes. To the left is a attenuated and high-end roll-off setting that is meant to be used with the front of a tube amp, or well, front of a guitar amp. The middle position is a somewhat attenuated signal, good for going into an effects loop, or also into a like a pedal chain into the front of an amp where you're going to lose some signal along the way. And the last setting here is the full output level designed to drive a power amp. The bright switch over here switches a bright cap in the preamp circuit. This is designed after the Marshall JTM45 or Plexi. They make 2 versions. This is actually the Plexi version. There's a few tweaks between those 2 circuits. Controls wise, we have 2 master volumes, master A, master B, and you can switch between those with this foot switch here. It is a 3-pole double throw latching foot switch. Treble middle bass, tone stack, pretty standard Fender / Marshall style tone stack. 2 volumes, volume 1, volume 2. They will, one will be brighter, one will be darker. That's just like the Marshall circuit. Of course, we have another foot switch to turn the pedal on and off. On the top here, we have that second master control. We also have the DC input jack. It is a 12-volt DC input with a center positive plug. So it's wired backwards from standard pedals. So it's going to be an uncommon AC adapter. They do include one with the pedal. And we have 1/4-inch input and output jacks, serial number. On the bottom here, we have some rubber feet, screws to hold the back panel on. The enclosure is a blue powder-coated steel enclosure. Looks to be about 18 gauge. The sides are vented where the 2 12AX7 tubes sit. That is it for the exterior. Let's go ahead and open up the pedal. So usually it is safe to take apart guitar pedals. Generally, you're not going to find the internals of a guitar pedal operating much more than 30 or so volts. However, that is not the case for this pedal. According to the documentation for Kingsley, this pedal runs the tubes at up to 270 volts, which is enough to give you a pretty nasty whack, and potentially under certain conditions could be life-threatening. So do not open one of these pedals if you're not used to working around high voltage. And if you do choose to open your Kingsley pedal, you do so at your own risk. So inside we have a kind of standard tube amp style build where we have a single board here with little dual connection turrets and all axial components mounted to that. There isn't a PCB per se. There's no printed traces. All the connections are made with either wire jumpers like so, or the connections jump to these terminal connections and then wires coming off those on the other side. On the turrets, each one of those has 2 connections, the inner connection and the outer connection. And so you can connect your components to the inner lugs and then wires out of the outer lugs. The inner and outer lugs are a single metal piece, so they are obviously continuous with themselves. So obviously we have the 2 12AX7 tubes installed in the pedal right now. Our new manufacturer tongue soles. Those are made in Russia, most likely made in the same factory, that new sensor factory in Russia that gives us the tongue soles, the Mesa Boogies, the Sovtecs. They're all sort of made in the same factory now. There's only a few factories actually in the world that still make tubes, the Russian one being one, Czechoslovakian is JJ, and then I think there's 2 Chinese manufacturing firms. As far as construction here, this is high quality tube amp style construction. We have shielded wires bringing signal in and out. All the wires are laid nice and neatly on the enclosure. The tube sockets here are mounted on standoffs. These are about 3/4 inch standoffs with screws. And you can see on the top here that the mounting side for the standoff where it meets the enclosure is actually pressed or peened into the enclosure, and then it's painted over. So that is something that comes from the enclosure manufacturer when Kingsley gets them, presumably. Or maybe Kingsley installs them, hard to say, but there is no like external nut or screw, which gives it a cleaner look. The 1/4 inch jacks are Cliff brand, which makes sense. It's UK manufacturer. Cliff is sort of the Neutrik of the UK. The tube sockets are the Belton type. That's a Korean manufacturer, which is a super common, high quality. It does appear to use star grounding, so there seems to be a single ground connection coming over here to a spot on the enclosure, which was blocked off during the powder coating process. And it appears all the grounds are coming back to that single point, which is a good idea. Potentiometers are all the alpha style. Going in value, the ones I can see, the 2 volume pots are audio 1 meg, so logarithmic 1 megs. Cannot see the treble value, but usually the treble value in a Fender Marshall tone stack is going to be 250K. The mid value is 25K, and the bass value is audio 1 meg. And the master control is also audio 1 meg, and this one I'm sure is audio 1 meg as well. Foot switches here appear to be the Gorva style, or the Love My Switches. That's sort of a teal green color. Nice feeling switches, less pressure than the blue switches. Should be this style switch here. These are actually even lighter. I got these just from Love My Switches. These are even lighter than these ones, so it might maybe just a different manufacturing run or a little bit earlier. But either way, the foot switches feel good. Definitely feel like it's not as gritty, it's smoother, and requires less pressure. On the bottom here is a little PCB, and this PCB is going to be most likely generating the high voltage for the tube plates. And to that effect, that's what it looks like. We've got an inductor here, a big filter capacitor, some voltage regulators, a little 8-pin dip package, some diodes, a high wattage 10K resistor there, and then just a couple wires coming off there from the board. The tubes are fairly accessible, so if you wanted to try some tube rolling in this pedal, obviously, heed the warnings I said at the beginning. Make sure if you are messing around with high voltage stuff, you know what you're doing. But they are fairly accessible, and you could definitely get in here and pull out the tube and replace it with a different one. Fair warning, Belton tube sockets are pretty stiff, so don't be surprised if it takes a bit of effort to get the tube out. On the upside, the tube is not going to come out just under normal use of pedal board banging around. Components all appear to be high quality. We do have 1/2 watt carbon film resistors. The yellow film caps here are all Mallory film caps. Bypass cap under there is Vichy, I'm pretty sure, and the brake caps here, or that's tone cap and brake cap, are CDE 500 volt mica caps. All right, so like I said, the Kingsley documentation alleges that the power supply in this pedal generates up to 270 volts for the tube plates. We are going to check that out right now. See what voltages we can get. Get the AC adapter. This is the adapter I got with this pedal. I bought it used, so I can't guarantee that this is the original adapter. But you can see on there, hopefully, we do have 12 volts output at 0.7 amps, and the polarity is center positive. All right, let's look for some voltages in here. So let's see. Red wire, I'm going to guess, is high voltage. Let's see. Yeah, there you go. 270, just as advertised. That appears to be going to the plates of this 12X7 right there. Let's check over on this side. 157 on this tube here. So this tube's running at a little bit lower plate voltage. So here's the cathode of this tube, 0.875 volts. On this side, 0.8 volts on the cathode. Here is the heater supply for the tubes, 11.8 volts. So 12AX7. We're used to seeing 6.3 volts for 12AX7, but that's because in tube amps, usually the heaters for the tubes are run in parallel. So the supply comes into the center tap and then it's 6 volts either side. In this case, it's generating a DC voltage for the tube heaters and it's running at the 12 volts. This makes sense for a pedal format like this because at the higher voltage, 12 volts, it's going to be consuming less current, which is just Ohm's law. Has to be the case. So 12AX7 usually is about 150 milliamps at 12 volts and 300 milliamps at 6.3 volts. One thing I want to see is how quickly the filter caps drain off in this pedal. Just in case for some reason you were disconnecting the power supply and then immediately touching inside the circuit. Let's see how much charge the pedal retains after disconnecting the supply voltage. So I've got the ground probe obviously connected to the enclosure, and the testing probe here is connected to the high tension supply for the second 12AX7 here. So let's disconnect power. Okay, so that drained very quickly, which means that the 12AX7s were warm and they immediately started pulling all the current out of that filter cap. That, or there is a bleeder resistor somewhere in the high tension circuit in order to drain off that filter cap once the power is disconnected. We can perform a second test to figure out which one it is, which is to let the tubes cool down completely and then provide the power, which will immediately charge the circuit up to potentially even a little bit higher than 270, and then pull out the power again, and then we'll see how quickly the filter cap drains. All right, so I've waited a couple minutes to let the tube filaments cool down. So what we're going to do is connect the AC adapter, which should immediately charge the circuit, and then I'm going to pull it right out just to see how quickly the circuit or the filter caps discharge when there's no current flowing through the tubes. Yeah, see 315. Yeah, so even with no current flowing through the tubes, wasn't long enough to heat up the filaments. We're still bleeding off a bunch of voltage. So there must be a bleeder resistor in the high tension circuit in order to drop the filter voltage down to essentially ground potential when the AC adapter is not connected, which is a good idea. It's just a fail-safe, in case anyone doesn't heed the warnings, to not be mucking around with high voltage if they don't know what they're doing. So you put in a bleeder resistor to drain those filter caps off and hopefully prevent someone from ruining their day or worse. All right, so that is the internals of the Kingsley Constable, a valve preamplifier from Kingsley Amps in the UK. Let's go ahead and put the pedal back together. All right, that's it for the teardown on the Kingsley Constable. If you have any questions or recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Gray Bench Electronics. Thank you for watching.